A simple harmonic oscillator has a mass, that's our M, right? This is our total energy, right? Amplitude, that's our X naught, right? And what distance when it's got a potential energy of 113 joules? Okay, so again, I think we got to like figure out, we are going to figure out the omega from this, right? So step one, we're going to use this formula. 1/2 m omega squared x naught squared, okay? Because I think we know everything except omega in this, right? So let's do this. Let's see. Total energy is 16.8 is 1/2 4.2. That's a 4. Okay, omega squared, which we don't know, but we do know the amplitude's 0.84 squared, right? So let's solve this for omega, right? Okay, so 16.8 times 2 to get rid of that, right? Divided by 4.2 divided by 0.84 squared. And this is going to be what omega squared is, right? So 11.337 is omega squared, and then of course omega is 3.367. 175, et cetera, right? And I'm going to store that. I'm going to go stow alpha w, stored in alpha. All right, so now we know what omega is. So now we want to know what distance it is from equilibrium when it has a potential energy of this. So luckily we have a formula for potential energy directly, right? 1/2 m omega squared x squared, right? So what distance is it? That's that, right? So it's only got 11.3. So 11.3 is equal to 1/2 4.2. We know that omega is 3.367175, et cetera, right? Squared x squared, right? So this is that answer right there. Okay. So now let's do the math here, right? So 11.3 times 2 to get rid of that. Sort of the same thing, right? Times 2 divided by 4.2 divided by the number I just got squared, right? And then I get x squared equals 0.4745. Ooh, a bunch of 9s. Isn't that cool? Like 9s seem to repeat. All right, let's square root that. So x is equal to 0.688912. So we have 3 sig figs, so we say that x is about 0.689 meters. Woohoo! There's harder ways to do this, okay? But that's, I think, the easiest way. All right. Woohoo!